All right, let's talk exams. You've put in the hours, you've memorized the reactions, you feel like you really know your chemistry. But then you get into that exam hall, and suddenly it feels like knowing the science is, what, half the battle? The other half is figuring out what on earth the examiner actually wants you to write down.
I mean, it's a huge source of stress, right? You could write an answer that is 100% scientifically correct, but if you don't use those specific keywords the mark scheme is looking for, poof, those marks just vanish. So how do we get inside the examiner's head?
Well, that's exactly what we're going to do today. We're going to pull back the curtain and decode a real AQA exam question line by line using the official mark scheme. Think of it this way. This isn't about cramming more chemistry. Nope. This is about learning to speak the language of the exam.
Okay, so the question we're tackling today is question 07, and our mission, should we choose to accept it, is to identify all the ions hiding in this one compound, potash alum.
First up, let's hunt down that potassium ion, the K+. This is where we start our investigation.
All right, so the exam asks for two things, plain and simple. Tell them the test for potassium ions, and then tell them the result. It's a classic two-marker. So what does that perfect two-mark answer actually look like?
And there it is. Seriously, look at that. This is straight from the mark scheme. For 2 whole marks, all you need are 3 words. The test? Flame test. The result? Lilac flame. That's it. No fluff, no long sentences. They just want those key words. It's that simple.
Okay, so the next part of the question kind of levels up. It's asking for a more high-tech way of doing the same thing, an instrumental method. This is where they're checking if you know about the more modern stuff we use in a lab.
And again, the mark scheme is super specific. The magic words you're looking for are flame emission spectroscopy. That gets you 1 mark. Then for the second mark, you just need to list one of its advantages. You could say it's more sensitive, more accurate, or even just that it's quicker. Any of those will do the trick.
Okay, potassium ion found. Now let's move on to the next piece of the puzzle, the aluminum ion, Al3+. And for this one, we're going to need a totally different test.
So the question actually helps you out here. It tells you what the student does. They add sodium hydroxide. All you have to do is say what happens next. So, what do you see?
You're gonna love this. The answer, for 1 full mark, is just 2 words, white precipitate. That's all they want. What's really interesting is the mark scheme actually says to ignore any mention of it dissolving at this point. Why? Well, because they're saving that for the next question.
But here's the catch, right? A white precipitate is a great start, but a bunch of other metal ions do the exact same thing. Think magnesium or calcium. So this is where we need to be clever. We need a second step, a confirmatory test, to prove it's really aluminum.
And of course, the exam setters know this. It's like they're leading you right to it. The very next question asks exactly that. What's the extra step, and what happens when you do it?
And here is the absolute key. The extra step is adding excess sodium hydroxide. That word excess is crucial. And what's the result? The white precipitate dissolves. It disappears. That's the confirmation, because only a couple of common ions do that. The mark scheme is laser focused on that word excess to show you know what you're doing. All right, we've bagged the 2 positive ions, potassium and aluminum. Now for the final piece of our chemical puzzle, the negative one, the sulfate ion. Now pay attention here, because this last part is worth a whopping 3 marks. That's a huge clue right there, telling you that your answer needs to be a bit more detailed than the others. So how do we make sure we grab every single one of those 3 marks? Okay, the mark scheme lays it out as a 3-step recipe. Step 1, add some barium chloride solution. Step 2, and this is super important, you have to add some dilute hydrochloric acid. That's to get rid of anything else that might interfere. And finally, step 3, the result. You see a white precipitate form. You need to mention all 3 of those things to get the full 3 marks. Miss one, and you lose out.
But here's a little pro tip, a little peek behind the curtain. The mark scheme actually says they'll also accept barium nitrate solution. So it's not always super rigid. Of course, if you used barium nitrate, you'd have to use nitric acid instead of hydrochloric acid to go with it. The point is, as long as your chemistry is solid, sometimes there is more than one way to get the marks.
Okay, so we've totally broken down this question. We've seen exactly what the examiner is looking for. Let's wrap it all up in a neat little summary, your ultimate checklist for full marks.
This right here, this is the whole game plan on one slide. This is your blueprint for success.
For potassium, flame test gives a lilac flame.
Boom.
For aluminum, add sodium hydroxide for a white precipitate, then add excess and watch it dissolve. Done. And for sulfate, add acidified barium chloride, and you get a white precipitate. If you can remember this table, you've cracked question 7.
So you see, it's not some big secret, is it? Getting top marks is all about precision. It's about knowing those crucial keywords, lilac, excess, precipitate, and using them in the right place. The mark scheme isn't there to trick you. It's a guide. It's the dictionary you need to translate your great chemistry knowledge into great exam marks. Honestly, by doing this, you're not just revising chemistry. You're learning a killer exam technique. You've officially cracked the code for question 7. Now imagine taking this same approach to every other topic. You'll start to think just like an examiner. So what are you waiting for? Go try it out.